Hey guys, welcome to Objective 2 of our first unit, which is piecewise functions. So I'm going to teach you of a new piecewise function, and that's the absolute value function. It's really like a linear function that's got this meeting point where it completely changes direction. And it just looks like a V or like a little upside down V. And it's a quite simple function if you have an understanding of linear functions and transformations. So let's get to it. The 10 pieces that you're going to be expected to analyze, really for any function. So we start with absolute value, but really with any function, I'm going to expect for you to know to have a full understanding of the graph, of the table, know how to evaluate with the function, know how to find any intercepts for the function, know two things about intervals, which is where's the function increasing and decreasing, or where's the function positive or negative? Where are the turning points of the function? What's the end behavior of the function? Where is the function symmetrical? And what are the transformations of the function? So let's get to it. First of all, I need to understand how to graph this. I am using function notation, and here is f of x equals -3, x plus 1, quantity absolute value bars plus 2. I can explore with this a little bit if I want to and sort of see what those numbers do if I want to. To create a table, I know that I can just go up here, add table, right? Or really what I'm going to do is I'm going to hit my settings and convert to a table. All right, so I want to look at the table and be able to look at some inputs and outputs, sort of see the pattern. I go from -1 to 2. That means, and then I see some symmetry. I go back to -1. It makes me think. I wonder what the output would be at -3. I wonder if it would be -4. Right? There's a lot of symmetry to these graphs. So I have some information right there on the Desmos file for you to copy down. Step 3 is one of the most important parts, doing an evaluation. With any function that you encounter, you need to know how to evaluate with it. And this is just practice on order of operations. So let's say I wanted to find f of -2. So the table tells me that f of -2 is -1. If I want to evaluate with it, I'm going to substitute -2 into my absolute value bars. All right. So here I go. -2 plus 1 is -1. The absolute value of -1 is +1. +1 times -3 is -3. And then -3 plus 2 gives me -1. So now you see why the output at -2 is -1. So you would be expected to be able to evaluate with any of these functions. Step 4, locating intercepts on Desmos is quite simple because I can just go to my x-axis or to my y-axis to locate the y-intercepts. Okay, so those are the intercepts, and so far so good. That's 4 out of the 10 steps. Steps 5 and 6 talk about intervals. When we mean intervals, I want you to think back to your first lesson on piecewise functions, where you saw the intervals beside of the function. So intervals are domain intervals. This is what I mean by intervals, domain intervals. So the first question is, where is this function increasing? So functions are read from left to right. So this function is increasing basically from -infinity, the x value of -infinity, all the way to, it stops increasing right here at x equals -1. Notice how I'm not acknowledging the y value, all right, when I'm writing this up. The function is decreasing from x equals -1 all the way to positive x infinity, okay? So that is written right here, where I am increasing and where I am decreasing. Then I can also ask, in what interval is the function positive? Well, when I say where's the function positive, we mean where are the outputs positive? So if the outputs are positive, well, it looks like this little section right here, this piece that is sort of that is above the x-axis. So that is the interval -1.67 to -0.33 or -0.33. All right, and that is written as well in step 6. Step 7 is finding the turning points, or max or min. You can locate that by just touching the point right there. So that is -1, comma 2. Step 9 is analyzing the symmetry. So if you look at this, you can tell that the symmetry is right here with the vertex. It's at x equals -1. All right. And then step 10 says, what are the transformations of this function? In other words, what you need to think about is, what are the numbers in the function rule actually doing to the graph? So -3 is affecting the slope. You can see that the slope is down 3/1. +1 has moved the function left 1, and +2 has moved the function up 2. And that is a complete analysis. There's an example at the bottom.